Welcome to session 4 of Unit 5, Introductory Statistics 1. Well, the session 4, we are going to consider the variance of discrete random variable. Remember, we considered the expectation of a discrete random variable. This time, we are going to consider the variance of a discrete random variable. Well, by the end of this session, you should be able to calculate the variance of a discrete random variable. Variance of a discrete random variable. Now, when we say variance of a discrete random variable, what do we mean? Well, the variance of a random variable is a measure of the degree of spread of a distribution around the mean of the random variable. So, in a simple sentence, the variance of a random variable, it measures how far each individual random variables spread around the central value, that's the mean of the distribution. So in other words, we could say that if you have a small value of variance, that will indicate that the value of the random variables are likely to be closer or to be close to the mean of the distribution. And of course, on the other hand, if you have a large value of a variance, it will also indicate that the random variables are likely to be far away from the mean of the distribution. Yeah, so you see how the random variables will be scattered around the mean, either close to the mean or scattered further away from the mean. All those are measured with the variance of a discrete random variable. So, variance of a discrete random variable. How is it calculated? Now, per the definition, a variance of the random variable x is given as the expectation of x squared minus the expectation of x all squared. So you see the difference. The first one, you square the x before you find the expectation of it. And the second one, after finding the expectation of x, getting a value, we square the whole value. And of course, you could deduce the standard deviation from a variance. When we take a positive square root of the variance, that's denoted by this sign called sigma. It is the same as the standard deviation. So standard deviation in a simple sentence is equal to the square root of a variance. Of course, the positive square root of a variance. And of course, we know how to calculate expectation of a random variable. So to come into the variance, to calculate the expectation of x squared, what it means is that it follows the same procedure. The random variable multiplied by its corresponding probability, and we sum everything one by one. So in this case, we are looking at x squared. So we square the random variable x and we multiply it with its probability, and that will give us expectation of x squared. Then after getting the expectation of x squared, then mean that we need to find the expectation of just x. And having the answer, we square the whole thing. Is it clear now? Well, maybe an example will cool your temper now. Now suppose that the random variable x has the PMF, probability mass function. So you see the random variable, and they are with its corresponding probabilities, or yes, they are corresponding probabilities. Fortunately, this one you have equal probabilities. They all have equal probabilities. 1/5, 1/5, which are not the case always. But all of them have equal probabilities. 1/5. It's a PMF because when you sum up the probabilities, it will give us 1. The other probabilities alone, summing them up, should give us 1. Now we have to find the variance. Find the variance. Solution. So you see that, remember that we need to find, first of all, find the expectation of x. And how do you find expectation of x? Expectation of x is multiply the random variable x with each corresponding probability and summing them up. Now this is the case, the probabilities are the same throughout, so it become a constant, or like not a constant, but a multiplicative factor among them. So we factor the 1 over 5 out. So taking 1 over 5 out, we could add up all the random variables. Minus 2 plus 0 plus 1 plus 3 plus 4. Before we multiply with each probability, because the probability 1 over 5 is a multiplicative factor for all of them. And this will give us 1.2. Remember, what we just find, this 1.2 is just the expectation of x. Also, remember, to find the variance, we also need to find the expectation of x squared. So coming to expectation of x squared, as we said earlier, since they all have the same probability, we'll still factor probability their probability 1 over 5 out. Then we square each random variable, that's x squared. So scoring -2, 0, 1, 3, and then 4. Before multiplying the result with 1 over 5, we will get 6 as the answer. That is not the expectation. That's not the variance. That's the expectation of x squared. The 6 is just the expectation of what? X squared. So the variance will now give us the expectation of x squared minus the expectation of x alone, all squared. And the expectation of s, then the expectation of x squared give us 6.0. So the variance now will be expectation of x squared minus expectation of x all squared. That will be 6 minus 1.2 squared. And that gives us the result of 4.5. So you can cross check with your calculator. But let's do with more example. Example 2. Example 2. The following table gives the number of cakes sold per day x, and the corresponding probability. So the days are here, the x are the days, that is 12, 13, 14, and 15. And each has its own corresponding probabilities. Now what are we to do? We have to find, or we have to compute the mean. Remember, we said the expectation is the same as the mean. So here, if you are asked to find the mean, it means that we have to find the expectation. We have to find the variance and also the standard deviation. And remember, standard deviation is just a positive square root of the variance, right? So now we are cool to go. The mean will be easier to find, right? Let's move on. So the mean, that's the A part of the question, that's the mean, or the expectation of x. That will be 12 multiplier with each corresponding probability 0.25 in that order. And after simplifying everything, it will give us 13.2. Also, remember, we need to also find expectation of x squared. So we are going to square the random variable x, that's 12 squared times 0.25 plus 13 squared times 0.45 in that order. You see, this one is quite different from the example 1 because we are multiplying each probability with its corresponding random variable, or multiplying the random variable with its corresponding probability, because the probability are not the same for this, unlike the example 1. We multiply each probability with each random variable, and this also gives us 175.1. Of course, if you answer the first part of the question, that's the A part, that's the expectation, that's the mean, that will give us 13.2. The second part, we need to compute the x squared first, expectation of x squared. After getting that, let's continue the solution. The variance will now be 175.1 as the expectation of x squared minus the expectation of x all squared, which is 13.2 squared. And if you do the algebra, you will get 0.86. That's the B part of the question. Then with the C part, we have to find the standard deviation. That is by taking the positive square root of 0.86, which is a variance, giving us 0.96. Thank you very much for watching. Let's look forward to the next session. That will be session 5.